Hello everyone, my name is Nidar Menmagiri and today we are going to learn a very important topic from computer network which is error control. This introduction the core topic how computer networks detect and correct error to ensure reliable communication. So let's go with the start, the introduction of error control. Introduction to error control. This slides explain the basic idea. Error control ensures that data sent over a network reaches the receiver correctly. Error may occur due to noise, interface, or faulty hardware. Error control is a typical handled at the data link layer and transport layer of the OSI model. Basically, the technique to detect and correct error in between the communication between the computer networks. And also it has been implemented on data link layer and transport layer. The second slide of my PPT shows the causes of error. The causes of error list common reasons why error happen in data transmission. The first is electric noise. Attention, which is a signal weakening. Second, attenuation, which is a signal weakening. Here, the list of causes of error. First, electric noise. Second, attenuation, which is a signal weakening. Third, crosstalk, interface from adjacent wires. Fourth, interface from internal source. And fifth, the hardware faults, the bad cables or router. Let's go with the new fourth slide, which represents the type of error described. Types of error describe two main types. There are two types of errors. First, the single bit error, that only one bit in the data is corrupted. Here, the burst error, multiple bits are changed, possible in a sequence where two or more bits can be changed in burst error, and in single bit, only one bit can be changed. My fifth slide shows the error detection and error correction. Here, the error detection versus error correction. It classifies the difference. Error detections identify that an error occurred but doesn't fix it. Error correction identifies and fixes the error. Detection is simpler and faster. Correction is more powerful but complex. But in error detection, there is only detective of error, and in error correction, the error has been detected as well as corrected. My sixth slide shows the error detection technique, outlines the method used to detect error. The error detection technique. First, parity check. Adds a bit to make total number of ones if it's even or odd. It's add when it's odd. Second, checksum, where the sum chunks of data send total for verification. Thus, the data segments which has been uh, changed or passed through the total amount of data for verification. And CRC, specifically, it's denoted as cyclic redundancy check, which in which the polynomial best checking. Here, the polynomial best technique very accurate for detecting burst errors. My seventh slide shows error correction technique. The forward error correction, which adds redundant beats, no retransmission needed. Here, there is no needed of retransmission. The redundant data is sent, which has been received can correct error without retransmission. Second, automatic report request, which receive detects error and asks sender to resend data. Types of ARQ, which is stop and wait ARQ, which is one frame at a time. Go back and ARQ, which is multiple frames sent, no error, all following frames are resent. And selective repeat, only the error erroneous frame are resent. My 8th slide shows the first type of ARQ, which is stop and wait ARQ. It sends one frame, wait for acknowledgement, and then it gives the another frame to the sender. This process works on the basis of sending an acknowledgement. Basically, here the acknowledgement represents the feedback towards the user. If the sender wants something, the user wants something from the customized uh, whoever the framework admin. Here, he wants something from him and he gives the acknowledgement, he gives the feedback to change this network or this communication lag between this or whatever the query they have been sent to the admin, then only they get answered and the feedback and acknowledgement has been cleared with the with this acknowledgement process. Here, if acknowledgement isn't received, resend then the frame has been resent. This is simple but inefficient for long distance or high latency communication. The second point of ARQ is go back and ARQ, which describes a more efficient method. Its sender can send n frames at once without waiting. If an error is found, all frames from the error onwards are resent, more efficient than stop and wait, but still can be wasteful. The third type is selective repeat ARQ. Selective repeat ARQ, most efficient ARQ method, only transmit the frame that were lost or corrupted, requires more memory and tracking but saves bandwidth. My 11th site represents Hamming code, which is FEC, where we are going to see FEC example, Hamming code example. Illustrate a real example forward error correction where Hamming code uses parity bits to detect and correct single bit error. Here we are given the data of 1011 Hamming code encoded as Hamming code 011001, widely used in memory systems and digital communication. My 12th slide shows the importance of error correction. Error control. Error control prevents data corruption in communication. It is essential for file transfer, video audio streaming, and reliable messaging and network apps. In conclusion, I like to summarize the key ideas of error control ensures data integrity. Techniques vary depending on application needs. Correct choice of method, which is detection and correction, improves reliability and efficiency. Here, the error control topic has been concluded. I hope you all get error control techniques and also the efficient amount to take error control in efficient time. If you have any question, you can comment on my channel. I'll surely give you a feedback or answer in very fast time. Thank you for watching my video. I hope you all get the point. See you in next video. Thank you guys.